Hello friends, welcome to my channel. Let's have a look at problem 1790. Check if one string swap can make strings equal. This problem is essentially the same as problem 859, the body string problem. So here we'll first read through the problem statement to digest the problem requirement, and then we compare with problem 859 and share the procedure and the code. First, let's look at the problem statement. So we are given two strings s1 and s2 of equal length. So notice that in this problem, it's assumed that s1 and s2 have the same length. So this is the difference from problem 859. So a string swap is an operation where we choose two indices in a string, so not necessarily different, right? So and then swap the characters at these indices. So if the indices are the same, so it corresponds to do nothing actually. So we are required to return true if it's possible to make both strings equal by performing at most one string swap on exactly one of the strings. So otherwise we return false. So this on exactly one of the strings, actually you can regard one of the two strings fixed and as the goal or reference. So here are three examples. So in example 1, so we can switch B and K, right, in S1 or in S2, right? So we return true. So similarly in example 2, so we can check the different characters corresponding to the indices, so we return false. So in the third example, so the two strings are identical. So in this case, based on the requirements of the problem or assumptions, we need to return true. So before we do the analysis, let's also look at the constraints. So first, S1 and S2 have length in between 1 and 100. So this 100 defines the problem size, so which is a small number. So the second constraint tells us again the two strings have the same length. The third one is about the characters in the two strings, so which are lowercase English letters. So with that said, we are ready to do the analysis. So let's first compare with problem 859. So in this problem here, so first it's given that the two strings share the same length. And secondly, it's allowed to not performing any swap, right? So we can perform one swap in the usual sense, or we can just do not perform no swaps. So as such, we just need to slightly adjust the procedure in problem 859. In such a sense, problem 859 is slightly complex than this problem. So the procedure is the following. So first, we find the indices where S1 and S2 have different characters. And then we call this number count. So actually in between, we can do early stopping, right, by checking if count is greater than 2, right? So in second step, if count is greater than 2 or count equals 1, so we just need to return false. And if count equals 0, so in this problem, we just need to return true directly. So this is the difference with problem 859. So if count equals 2, so then we just need to check swap. So we assume the two indices are I and J. So we need to return if this condition, S1I equals S2J and S1J equals S2I. So this is check swaps. So with that said, we are ready to do the coding. First, let's initialize a count variable that is 0, right? So, and also I'm going to record the two different indices if there are. So we get aux is a set. because we are paying attention to the indices, and also we want to compare the two characters in the same position of S1 and S2. So we are going to use enumerate function and zip function. So for I, character 1, character 2 in and enumerate, and zip S1, S2, right? So if character 1 does not equals to character 2, so in this case we are going to increment the count by 1, and then we add this index to the set aux. So let's do an early stopping. So if count is greater than 2, so in this case we just need to return false directly. And then after we exit this for loop, if nothing has returned, so we check the 3 cases, because in this, after this for loop there are 3 possibilities: count equals 0, or equals 1, or equals 2. So let's see, if count equals 0, right, so we just need to return true in this problem. And then if count equals 1, so we just return false. And other case, actually, we can use else, or just write like this, making it a list. So if count equals 2, then we can get the 2 indices. So aux pop, so we can use the pop twice. And then we just need to return the check swap result. S1i equals S2g, and S1g equals S2i, right? So with that done, so I guess that's it for the coding part. So now let's do a check for the test cases. Yeah, this passes the back. Now let's use an identical one to check, right? So this we should return true. Yeah, so this return true. So now let's check for the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this problem and this video. So this problem itself is not complex. So thank you.